Hello everybody and welcome back. In this video, we will discuss how to blink 4 LEDs on the Raspberry Pi Pico by turning 2 of them on for a particular amount of time while the other 2 stays off, and then the first 2 would go off and then the other 2 would turn on and stay on for a particular amount of time. So basically we want to make the first 2 on while the other 2 stays off and the last 2 on while the first 2 stays off. So that is what we want to achieve here. So I'm going to make use of the same connections that we have used in the previous videos. So as you can see, I have connected the LEDs to GP2, 3, 4 and 5, and then the cathodes of all the LEDs are connected to a common ground here. Okay, now coming to the code, you can see that we have defined a constant integer called num LEDs, which is equal to 4, and this represents a number of LEDs that we have. And then we have a constant integer array called GPIO pins, and in this we are specifying the pin numbers to which our LEDs are connected. So they are 2, 3, 4 and 5. So this 2, 3, 4 and 5. So they are the elements in the array. And then I am again defining another constant integer called run rate, which will be used to specify the delay that we want to give between the blinking of the LEDs. So here I'm specifying it to be 500, which means 500 milliseconds, and we can change it as required. Alright, now coming to the setup function. In the setup function, as usual, we are setting all the LEDs as output. For that, we run a loop using the variable LED, which goes from 0 till less than num LEDs. That means it will go from 0, 1, 2, 3. So that it represents the indices of the array 0, 1, 2, 3. And then each of them are set to output pin mode GPIO pins of LED. So this represents the elements of the array one by one starting from 0 till 3. So each of the LEDs are set as output. So we have initialized all our LEDs. Okay, now coming to the loop function, which will run repeatedly. In the loop function, you see that I am calling one function called control LEDs, to which I am passing the parameter run rate, which is equal to 500. Now this control LEDs is a user-defined function. That means it is a function which I have defined, and we can see that this is the control LEDs function. So basically inside this loop function, we only have one statement, that is we are calling the control LEDs function. Alright, now coming to the control LEDs function, we see that the return type is void, and it just takes one parameter, which is the run rate. And let's see what we do inside this control LEDs function. So initially we are trying to blink the first 2 LEDs. That means we are trying to turn on the first 2 LEDs while the other 2 stays off. So for that, I am running a loop which starts from LED equal to 0. So LED is a variable used for iterating over the loop. It starts from 0 and it goes till less than num LEDs divided by 2. Now why is this? This is because I want to only work with the first 2 LEDs now. So that is why I say num LEDs divided by 2. So num LEDs is equal to 4. Now 4 divided by 2 will be equal to 2. And this condition is LED less than. So it is LED less than 2 would come here. So less than 2 means it will be running from 0, 1, and it will not come to 2 because it is not less than or equal to 2, but it is less than 2. So it will go from 0 and it will come up to 1, 0 and 1. Okay, so that is what this loop will do. And inside the loop, we are saying that digital write GPIO pins of LED. So LED will be 0 in the first iteration and 1 in the second iteration. So it will represent the array here. So it represents the first LED and the second LED. Okay, so both of them are set to high. So by running this loop, the first 2 LEDs would turn on. And then we give a delay of run rate, which is 500 milliseconds. And then after the run rate, after that delay, we have to make sure that these 2 LEDs which were turned on are now again turned off. So for that, we again run a similar loop from LED equal to 0 to LED less than num LED divided by 2. And we are saying digital write GPIO pins of LED low. That means GPIO pins of 0 and 1, which represents the first and second LEDs, will be set to low now. And again, we are giving a delay of run rate. That means a delay of 500 milliseconds. So essentially what we have done here is we have turned on the first 2 LEDs for 500 milliseconds and we have turned them off for 500 milliseconds. Alright, now we have to do the same thing for the last two LEDs. So for that, we run another similar loop, but this time the loop will start from LED equal to num LED divided by 2, because we have to start from this particular LED. And what is the index of this LED in the array? This is 0, 1, 2. So it will start from 2. The index is 2 for this. So num LEDs, as we know, is equal to 4. 4 divided by 2 is equal to 2. So we say LED equal to 2 so that it starts from this particular LED. And it should run till less than num LEDs. So num LEDs is 4. So it is less than 4, not less than or equal to 4. So it will run from 2, 3, yes, till 2 and 3. From 2 to 3. And what do we do here? We again say digital write GPIO pins of LED high. That means we are setting those two particular LEDs to high. And which are the two LEDs? LED index number 2 and 3. That is the last two LEDs. So they will be set to high, and we give a delay of run rate. That means a delay of 500 milliseconds. And similarly, we have to also turn them off after turning them on for 500 milliseconds. For that, we run this loop again. You can see the things in the loop are the same. The only difference is that we say digital write GPIO pins of LED low. We are now setting those two LEDs, that means the last two LEDs, to low, or we are turning them off. And again, we are giving a delay of run rate, that means a delay of 500 milliseconds. And then the control LEDs function ends over here. Alright, so we see that this complete thing that we have discussed is inside the control LEDs function, which is a function that we have defined. And the control LEDs function is called inside the void loop function. That means the void loop function would repeatedly call the control LEDs function. And in the control LEDs function, what happens? The first two LEDs are turned on and off. And after that, the last two LEDs are turned on and off. And there is a delay of 500 milliseconds between each turning on and turning off. And this would continue, and we can achieve a blinking where the first two are on and the last two are off, and then the last two are on while the first two are off. Okay, so let's run the simulation to see if it is working as expected. Yes, we can see that it is working as expected. The first two are turning on for 500 milliseconds and going off for 500 milliseconds. And the last two are turning on for 500 milliseconds and they are turning off for 500 milliseconds. So it may be a little difficult for you to understand the delay because the delay is quite less. So let's increase the delay a bit. Let's make it, let's say 1500 milliseconds and run it again. So you see they are turning on, off. And then these are turning on and they are off for that particular delay or run rate that we have given. And it is continuing in that way. Okay, so that is how we can achieve this blinking of 2x2 LEDs. Alright, so I hope this was clear to you. And with this, we have seen that there are different patterns in which we can blink our LEDs using the Raspberry Pi Pico. We have discussed quite a few of them in this playlist. So we will continue to do more experiments as we go ahead. Thank you for watching and see you in the next one.